putting myself on Meet. So I hope you all can hear me. A very good morning to all of you. Once again, this is the last and concluding part of our introduction to digital image processing, that is steps in DIP. We are going to look into what we have already seen is a little bit of history of DIP, and we have already talked about the various part of the spectrum where the image is taken. Today we are going to learn some of the important steps that we take in DIP, and we will talk about components of an image processing system. So these are the two parts in this lecture. And we will Thank you, Oliver. Thank you, Anamika, telling me that you can hear me. So, going ahead, we have already discussed a lot of things about DIP, a few more things, and we will conclude the introductory part. So, what are the various steps in DIP? The first step is looking into the problem domain. As we have seen in the last few lectures, the problem domain of present day DIP can be from anywhere. It can be from space, science, forensics, medical, geographical imaging, simply imaging for aesthetic sense, biomedical. The We are dealing with images at almost in every sphere of life. So a problem can occur where an image processing can offer a solution, can be anywhere in any domain of life. So in the space, for example, if you have taken an image with a telescope, it might need some processing to get a particular galaxy or particular section of sky clear. Or in case of forensics, you might need to improve the fingerprints of the evidence which is available. So it can vary. It is now routinely used in studying ancient history, archaeology, etc. So imaging is a very important component, and the problem domain can come from any walks of life these days. So that is our first starting point in image processing, that why do you want to process an image? Like you might need to process image for various reasons. So one of the reasons also could be, which is very common, that you want a person in a particular photo, want that person to look good. So you will remove blemishes, color the hair, etc., etc., etc. So all these are the examples of the problem domain. You might need to resurrect an old photo. So suppose if you have a photo of your grandparents which has gone yellow because earlier there was no digital photo was kept. All the photos were kept in printed form, and with time they turned yellow. So all these photos you want to resurrect back. If they are black and white, you might consider to convert them into color. So All these are the problem domains. Now, image acquisition can happen in various ways as well. So that is the next step generally. You need to acquire the images. Camera is one of our chief source of acquiring image, but camera is our one of the chief source of acquiring the image, but not the only source of image acquirement. We can have a scans as well these days. So, for example, when you go and get your sheets xeroxed, the xeroxing machine is nothing but scanning your document. And there are many other different type of scanners for different purpose. Video is another source of video camera. You take a frame from a video camera and that will give you an image. But this is the image I'm talking in the visual light or visible light section. Your image can come from various other parts of the spectrum, and those cameras don't look like our normal regular camera. For example, if some equipment is capturing, say, gamma ray radiation from a distant supernova, then that will not look like an ordinary camera. In fact, you will be surprised to see its form that it is a camera at all. And there could be non-radio wave photography like sonography, etc., sonar, where the sound waves are converted into images. So image acquisition is the next part. We are going to talk a little bit about image acquisition, but per se, image acquisition is not the problem of DIP. The DIP begins once the image has been acquired. So, in that sense, we are not looking at the ways of acquiring the image. However, in some cases, you would find that the the way you process the image is very closely related to the way you acquire the image. So we will discuss that part at some later time, maybe not now. Image filtering is one of the basic steps in DIP. You rotate, you crop, you flip, you control the brightness, contrast, color temperature, brilliance, etc. etc. So we know how to make these adjustments in our images. So these are the basics. Then image might get corroded if it's an old image. There can be noise, or even if it's a new image, then there could be noise because of different reasons. So the noise identification and its reduction is important. So image restoration is one of the important steps. Now, how to deal with color images. So far, whatever we have discussed is common for both, but color images have more complications because they have more layers of information which could be uh, decoded separately, processed separately, and maybe combined at the end. There are different color spaces also which are available. So we are going to look into those things. What are the other steps? So changing the resolution. So if you have like say 100 pixel by 100 pixel image, you want to change it to say for some purpose, you want to change it to 300 by 300 pixel. So how do you change the resolution? The process is called wavelet transformation. compression. How do you compress an image? Because you need compression because you don't want the image to be too large so that the memory requirements are huge. If it's a large image, then it's more difficult in present day world to upload, to share, etc. An image, same image can be of 5 MB also, and the same image can be of 100 MB as well. So, depending on what format you are using and how much memory you are allocating to it. So, the compression is a very important step. Then, morphological changes to analyze, you want certain features of the image to become more prominent, to grow in size, or you want to suppress certain other features, you can make morphological changes. You can do segmentation as the word suggests. Segmentation is the division. You can divide the image into its components. You can identify a particular component. Suppose you want to identify disks or rings. You can identify those components or features, and you can count them or further process them. Then pattern identification. So there could be similar patterns. You might need to identify them. So, and then compare it. Those who have done video analysis using tracker, they know that the auto, and if you have used auto tracker, then you know that auto tracker works on this principle. You give it a pattern, then it compares with that pattern in the entire image and keeps marking automatically. So these are the various important steps in this course. Maybe we are not looking to do all the steps, maybe few of them, but as your work grows in scientific domain, you will realize that you need to learn more and more of DIP sooner or later. So what are the different components of an image processing system? So now imaging started long back, 1848 or 1849. Remember, I'm talking about middle of 19th century. 1848 or 1849 was the time when the first photograph was taken. And very soon, photography grew very quickly because people wanted to see their photos. As the photography grew, the image processing also started. It first started in the dark rooms of various photographers, and if you have seen the dark room of photographer, it's good. If you have not seen the dark rooms, which were very prevalent until year 2000, in fact in our college for a very long time we had a digital, we have a photographic darkroom, and those who are from Xavier's, for them the last room which we have used for acoustics experiments, small little room, was actually being used as a dark room for uh, development of photographic films, etc., for a very long time. It's only with the advent of digital photography the dark rooms um, cease to exist. Now we are having what is called a digital darkroom. So if you have seen it, it's fine. If you have not seen it, then I always recommend students to watch the movie called Jane Bhi Do Yaro. So that's a 1982 or 83 movie. Uh, a very good print is available on YouTube. So please watch that movie. It's a story of two photographers struggling with the themselves and struggling with system, and in that they they come across a few unusual incidents which they accidentally photograph, and then I will not open the suspense of the movie because it's a suspense drama, so you people should watch it. But and there are certain places where they have elaborately shown their darkroom, the enlargements, etc., etc., etc. So please visit that. Please watch that movie. It could be fun. It's basically a comedy plus satire plus drama plus little bit of suspense. The name of the movie I'm repeating, Jane Bhi Do Yaro. So please watch that so you will get some idea. So back then when computers were not there, digital was not there, image processing did exist. And there are number of photographers world over who have contributed for image processing concepts. So, I mean, I would also recommend you people to read a brief history of photography from anywhere, and you will find that how the in the early part of 20th century, still computers were far away. People tried to make the contrast enhancement, brightness enhancement, etc., all in a dark room. It was fairly laborious work and very sensitive work because a lot of chemicals were involved. And a photographer was supposed to be a master technician. In society, he was a very much a valued person unless and until the advent of digital photography happened when everybody became a photographer. So before that, the digital processing was there. Sorry, the image processing was there, but digital image processing was not there. Digital image processing all started around 1922 23, as we have discussed in transmission of one image transatlantic. But it really did not pick up further until the high speed computers arrived. So basically, major developments happened in 1960s and 70s with the advent of high-speed computers, computing algorithms, etc. And maybe in last 20 years when the entire photography finally moved to digital photography. So in the present day image processing system, the one of the important aspect is image sensor. Image sensor, as you all know, it's basically an analog sensor. It is not a digital sensor, surprisingly. I mean, many people would feel that the sensor is digital. So sensor works in a very analog manner. The light falls on it and it emits electrons, which is proportional to the number of photons falling on it. So if the intensity is more photons will fall, more electrons will be emitted. So it's a photoelectric effect which is being used. Then that image sensor uses specialized hardware and software to convert those number of electrons into, when the electrons are liberated, they will generate a voltage. That voltage will be used by an analog to digital converter to convert into a digital number. So very important role here is the role of an analog to digital converter. Ajay sir will cover that part, analog to digital converter, in his course. So do remember that that's a very important component in DIP. Image sensors primarily record in analog form, and and ADC converts it into a digital form. And that's a hardware, it is not done by software. Once the digital form is created, then you can process it further to make your image consolidated, and finally an image reproduction can happen. So image sensor and then specialized hardware. I'm not writing the details. You need amplifiers, some analog to digital converters, etc. Not giving all those details here. As I said, strictly they don't fall in the domain of DIP. And then it is fed to the computer. Both computer and the specialized hardware at that instant can use a DIP software. So like you can go to your settings and you can say that you want your images in black and white form. And then henceforth whatever is clicked will go in the black and white form. So some DIP software, native DIP software is always present along with the camera, which is being used by the specialized hardware as well as the computer. And there could be some advanced softwares. So advanced software can be anything like an image, like a Snapseed, like a Photoshop, whatever you use. So you can use your those softwares by both. Then computer has an access to the mass storage, your main memory. Computer can send the data there and retrieve the data from there. Computer also has an access to a display or a printer. So it can print, it can display, and then computer can send it to a network where it can be shared. So that is how a modern present day image processing system looks like. Now it's a digital image processing system. Images are converted into number format, and then what we are processing basically are the numbers. Okay, with that we can stop here. Please wait for the next part to begin.